All right, let's move on to number 20. I've written out the reaction for you and restated the question. So we have a balanced reaction that's occurring all in the gas phase, where 2H2 gas plus nitrogen monoxide gives water or water vapor and 1/2 N2. Okay, so we don't have to multiply this whole thing out by 2 to get rid of the fraction. In fact, the numbers that are up here are not important in answering this question. It says that we know independently that the reaction is first order in hydrogen gas and second order in nitrogen monoxide. And we're asked to give the rate law expression. And when you hear that term, the rate law, it always has the form of, it's a way of writing the rate, but it always has the form of, I think you know this by now, the reaction rate constant times each one of my reactants, not products, but the reactants. And we don't pay any attention to the stoichiometric coefficients. So it's H2 times concentration of NO. And yeah, it's in the gas phase, and I could also write it in terms of pressure, but we conventionally use concentration. Now, it's not complete yet because it says that from experiment, we know the reaction orders. So we know that we have to do experiments to determine the reaction order. It's first order in hydrogen, so there's a 1 there, and I refrain from writing it in. And it's second order in nitrogen monoxide, so there's a 2 there. So the reaction is in fact third order overall, and this is the way that I would write the rate law expression. And if we look at our choices for number 20, that corresponds to B. Okay? Let's do 21, and we'll just do 20 and 21 on this clip, because the one after that is a numerical problem. Okay, number 21. We're getting through them slowly. 21 says the rate data from a chemical reaction shows that doubling the concentration of A with the concentration of B remaining constant causes the rate to increase by a factor of 4. Okay, so if I double the concentration of A, I get a 2 squared factor change in the rate. So some of you will recognize that right away as being second order in A. And so the correct answer is D. But let me show you. Clearly this is a rate that depends on both B, we don't know the order, and A, and we don't know that order. But it said that it didn't change B in this experiment, it just changed the concentration of A, and it did so by doubling it. So it doubled A, but it got 4 times the rate. But all it did was double A. So then I know what the question mark is. It must be 2 squared to give me 4, and therefore the reaction must be second order in A. And that answer is D for 21.